This video is on Pythagorean triples, also known as Pythagorean triads. If you're surfing the internet, you'll see that that's another name for it, used in other countries. We do call them Pythagorean triples, or Pythagorean triads as well, actually. What is a Pythagorean triple? So it's just a set of three integers, okay? Three integers which satisfy Pythagoras' theorem, and an example is 3, 4, 5. So in order to satisfy Pythagoras' theorem, we know that if we square the hypotenuse, it should equal the sum of the other two sides squared. Well, we can treat these three numbers in the triple, or in the Pythagorean triple, and we can square the hypotenuse. Now, if we're going to look at which one's the hypotenuse, it's clearly the largest number. So what we're saying is if you square this 5, which is 25, it should equal the sum of the other two sides squared. In this case, it'd be 3 squared, which is 9, plus 4 squared, which is 16, and 9 plus 16 is 25, which is 5 squared. So really, we're treating this set of three integers like they're the sides of a right-angled triangle. So the three integers could be the sides of a right-angled triangle. They're just called Pythagorean triples or a Pythagorean triad because they're listed as a set of integers. There is no triangle drawn, and we're not treating them like they're the sides of a right-angled triangle, but they could just as well be. So one thing you'll be expected to do is determine if a set of integers is a Pythagorean triad or a Pythagorean triple. So here's an example where we've got, grab my pen, where we have three integers for 11, 22, and 30, and we want to determine if they form a Pythagorean triad or a Pythagorean triple. So if you're going to work out if it is a triple, then we need to determine if it satisfies Pythagoras' theorem, very similar to what we did in the last video, but we were determining if a triangle was actually right-angled. In this case, we're just looking at, do these three numbers form a Pythagorean triad, which it's almost the same thing, except for instead of looking at it like it's a triangle, we're just going to treat those three numbers, we're going to call them A, B, and C. C for the hypotenuse, which is the largest of the three, and we're going to check if these three numbers actually satisfy Pythagoras' theorem. So, if these three numbers satisfy Pythagoras' theorem, well, we can take the C and square it. Let's have a look what C squared is. That's 30 squared, which is 900. You can use a calculator. I'm hoping you know that 30 times 30, well, 3 3s are 9, and then we've got the 2 zeros. We're going to check if C squared equals A squared plus B squared. For this type of question, I'm not using left-hand side, right-hand side, because I don't have a left-hand side and a right-hand side over here. I just have three integers. So what I am doing is I'm giving them a name. This is important to actually give them a name, A, B, and C, which links this name to your actual solution. Okay, it's important your solution makes sense. The solution makes sense because I've actually given the three sides a name. So I've found C squared, and now I'm going to go and find A squared plus B squared. So A squared plus B squared. If I look at my A and B from my labels, well, A squared is 11 squared, and B squared is 22 squared. So that's going to be 121 plus, I'm going to work out what 22 squared is on my calculator, 484, 484, and then I'm going to add them together. 484 plus 121 is 605. Wow, what do we notice? Just like before, I'm comparing C squared to A squared plus B squared. And if these three numbers were a Pythagorean triple, well, my C squared should equal the A squared plus B squared. But we can see that these two yellow highlighted numbers are not equal. So I would tell my examiner, or whoever will listen, that C squared does not equal, that's this little symbol here, does not equal A squared plus B squared. And so therefore, the integers, the whole numbers, are not a Pythagorean triad or Pythagorean triple. Okay, a conclusion's important. It shows whether you fully understood the question. So for me, stopping at this line here is not good enough. That doesn't tell me whether you've decided or not whether they form a Pythagorean triad. It's from this conclusion here where you're saying, no, they're not, that I know that you fully understand. So remember that your solution should really match my solution in terms of its clarity. Let's have a look at another example here. We're going to do the same thing. I'm going to call the sides A, B, and C. I can see that C's over here. It's the biggest. It doesn't matter which one's A and which one's B, but I'll just go in alphabetical order. And I'm going to square the hypotenuse, which will be 29 squared. I'm going to work that out on my calculator. Gives me 841. 841. And then I'm going to work out A squared plus B squared. So my A is 20, so I'm going to square the 20. My B is 21 squared. So 20 squared, that's 400. 21 squared is 441. 441. Add them together, I get 841. And let's have a look at what we notice. So I've got here C squared. Got over here A squared plus B squared, and what can we conclude? Well, I can see that C squared does in fact equal A squared plus B squared. That means that Pythagoras' theorem holds true for this set of three numbers. So I would then write down, therefore, the integers do form a Pythagorean triad. All right, I hope that makes sense, seeing the two examples. Let's have a look at one more question that you can be asked on Pythagorean triples or Pythagorean triads. We've been told here that 32, x and 68 form 32x and 68 is a Pythagorean triad. So these three numbers, these three integers, 32x and 68 is a Pythagorean triad, meaning these three integers are a Pythagorean triad. What does that mean again? Well, it means that if I square C, which in this case would be 68, you can assume that they are written in ascending order. If we square the 68, then it should be equal to the sum of the other two sides squared. So in this example, I haven't given you all three integers. What I've done is left one out and made it x, and then told you it is a Pythagorean triad. In the other examples, you had to determine if the three integers formed a Pythagorean triad. This time around, I'm telling you it is a Pythagorean triad. Now use that information to find x. Well, if it is a Pythagorean triad, then we know that the C squared, which is 68, should equal B squared plus A squared, or A squared plus B squared. It doesn't matter whether you start with 32 squared or x squared, because with addition, order doesn't matter. So I've put the x squared so I can have my unknown first. Now we're going to work out or use our calculator to square these numbers. So 68 squared is 4,624. X squared here. And then I'm going to square the 32. That gives me 1,024. And now I can move this 1,024 by subtracting it. Using my inverse operations, I can see that this would cancel those two. So I'll be left with x squared over here, because I'll be left with the x squared all by itself. And then I'm going to do 4,624 minus 1,024. That gives me 3,600. To get rid of this squared, I will square root both sides. And when I square root, it cancels out the squared. They're inverse operations, so that undo each other. So I'm going to square root the 3,600. I hope you know that the square root of 3,600 is 60. Because 60 times 60 is 3,600. So x equals 60. Oh, actually, I really don't. I was just thinking, do I have anything else to write? Well, all they asked me to do is find x. And if I read this solution, I've applied Pythagoras' theorem here, and then I've solved all the way down to finding the value of x. So there's really, I'll just put x equals here, it's a bit clear, there's really nothing else for me to do. So if this x is 60, 32, 60, and 68 would be a Pythagorean triad. All we had to do was solve for x. Once you've answered the question, you are done.